This is for Year 11 methods, Year 12 methods. It comes out of 16D. It's question number 5. The weights of cats are normally distributed. So I've got the normal distribution. And it's known that 10% of cats weigh more than 1.8 and 15% weigh less than 1.35. What is the mean and what is the standard deviation? There are two unknowns, the mean and standard deviation. So I'm thinking simultaneous equations. Okay, so if the weight of cats is normally distributed, this is the weight of cats, there'll be a mean there and there's some standard deviation. And I know that when that is 1.8, that probability is 0.1 because 10% weigh more than 1.8 and 15%, 0.15, weigh less than 1.35. So since I don't know the mean and I don't know the standard deviation, I'm going to have to use the Z value. So I'd like to consider the Z distribution, where I know that the mean and standard deviation of Z is 0 and the standard deviation is 1. And I'd like to use my calculator to find the Z value that gives this as being 0.1 and the Z value that gives this probability to be 0.15. So I'm bringing my calculator and I'm going to go interactive distribution inverse normal. It's going to be a left tail with a probability of 0.15 with a standard deviation of 1 and a mean of 0, okay, and that gives me a Z value of negative 1, there's negative 1.0364, and if I'm looking for, I'll do it again, interactive distribution inverse normal, and I'm looking for a right tail, and a right tail where that probability is 0.1. Okay, and that gives me a Z score of 1.28155. Okay, now I know that Z equals X minus the mean over the standard deviation. So, using this piece of information here, I have 1.28155 equals 1.8 minus the mean over the standard deviation. That's equation number 1. And I have negative 1.0364 equals 1.35 minus the mean over the standard deviation, which is equation number 2. I'll bring in my calculator at this point. So I'm going to bring up the keyboard, I'm going to bring in simultaneous equations, and I have 1.28 equals fraction 1.8 minus, I'll use X for the mean, divided by Y, which is the standard deviation, and I might put that equation into a new line, and that's going to equal this other value for Z, and I can make that 1.35. And I'm going to solve that for X and Y. Execute. So I've got a mean of, I've got my calculator again, 1.55, and a standard deviation of 1.94. And that makes sense because the mean of 1.55 sits there. Here we go.